Before we go into DQL, there are two more concepts we need to understand on a high level. One, OLTP versus OLAP. Two, DIM versus fact table. These concepts will be explained in depth in the data modeling course, but just touching on high-level overview here, because when you see a DIM table or fact table while writing SQL queries, you know the purpose exactly. Let's get started with learning what is OLTP versus OLAP. Let's start with how Amazon stores its everyday data. Every time thousands of people place an order, add items to their cart, or update their address, that information needs to be saved right away and correctly. That's what an OLTP system does. It stands for Online Transaction Processing. OLTP is built for speed and accuracy because millions of customers are shopping at the same time. If the system isn't fast, the website would lag or crash. If it isn't accurate, orders could get mixed up or payments might fail. So OLTP is designed to handle thousands of small transactions every second, making sure every order, every payment, and every delivery detail is recorded perfectly. All of the transactions handled by OLTP, orders, payments, and deliveries, are continuously sent to another system called OLAP, or Online Analytical Processing. This is where Amazon stores and organizes historical data for analytics, reporting, and dashboarding purposes. Inside Amazon's OLAP warehouse, data isn't stored as individual transactions anymore. It's organized by categories like products, customers, regions, and sales, making it easier to summarize and analyze performance over time. OLAP helps Amazon answer big questions. What were yesterday's top-selling products? Which regions had the highest revenue? Or how are delivery times improving over time? Instead of one order at a time, OLAP looks at trends and patterns, helping Amazon understand its performance across millions of transactions. All the information inside OLAP is stored in tables, just like in SQL. These tables organize data so it can be queried and analyzed easily. There are two types of tables in OLAP data warehouse: dimension table and fact table. Dimension tables describe the details, things like products, customers, or dates. They hold descriptive information that gives meaning to the data: who, what, where, and when. Fact tables, on the other hand, store measurable information. They record numbers: how much was sold, how many items were ordered, or how long delivery took. Fact tables capture the measurable outcomes, the how much and the how many behind every transaction. Both fact and dimension tables work together to make data meaningful. Dimensions provide context: the who, what, where, and when. Facts add the measurable part: how much was sold, how many items, or how long it took. Together, facts and dimensions tell the full story, turning raw data into insight. Let's look at what fact and dimension tables might actually look like in an Amazon e-commerce database. On the left, we have the product dimension table. This table doesn't store transactions. Instead, it describes each product Amazon sells. The product underscore ID column is like a unique identifier or reference number for each item. It's what helps the database recognize that a laptop number 101 is different from phone number 102. Then we have columns like product name, category, and brand. These are descriptive attributes. They tell us what the product is, which category it belongs to, and who manufactures it. Now, on the right side, we have the sales fact table. This one records actual events, things that happened in the business. Each row represents a completed order or sale. The order ID uniquely identifies each transaction. The quantity column shows how many units were purchased. The sale amount shows how much revenue that order generated. And order date tells us when the sale occurred. But notice that the fact table also includes product underscore ID, the same one that exists in the product dimension table. That's not by accident. This shared column is the bridge that connects both tables. It lets us write SQL queries that combine the numeric information in the fact table with the descriptive details from the dimension table. For example, we can ask questions like, what was the total sales amount for laptops in January? Or, which brand generated the most revenue last week? And that's exactly why product underscore ID exists in both. It acts as the link that turns two separate tables into one complete story. You will understand this more when you actually write SQL queries in DQL section. So let's recap what we learned in this video very quickly. Data begins in OLTP systems built for speed and accuracy in everyday transactions, then moves into OLAP systems, organized for analysis and insights. Inside OLAP, data is split into dimension and fact tables. Dimensions hold descriptive context: who, what, where, and when. Facts hold numbers: how much and how many. Together, they form the foundation for SQL, the language that turns data into answers. Also, these concepts will be covered in an in-depth manner to make you ready for interviews in our data modeling course. Just a basic understanding is expected to move forward in this SQL course. Thank you for watching this video. See you in the next section.